You think if I asked her?
No.
She said you could switch to the first one. Who doesn't want the first one? I want the first one. I want the first one.
You guys have an author.
You can tell me who's your editor. I don't know.
I know I didn't do it. Yeah. I thought the question is confusing. Like how far?
Okay, I'm doing like at least a little. At least a 3.
That's great. I'm definitely.
Yeah, it is. At least.
I mean, if you get that.
No, it's not. It's gonna be 4.
Oh. Go ahead and if you write that.
All right, guys, real quick.
Like.
Determine the average velocity on the interval from 2 to 8 if the velocity is given by v of t equals t squared minus 4t plus 1. Set it up. What is the average velocity? You have to know this if you are present yesterday.
I guarantee you it's
Average blah is what? The integral of the
PD minus
Blah.
over a.
So I'm going to integrate the actual blah from 2 to 8 divided by 8 minus 2. So to integrate, guys, I keep seeing you guys integrate. And listen, I know we're getting started, but the test is getting close. I keep seeing you guys integrate by just literally plugging the 8 in, plugging the 2 in. You're forgetting to integrate. I love that you actually remember the fundamental theorem that says plug the 8 in and plug the 2 in, but you can't forget to actually integrate, right? Now, if it's the second fundamental theorem with the ddx out front, then yeah, that's going to cancel and you're just going to plug the function value in. But in that case, you're not plugging both in anyway, right? Second fundamental theorem, you ignore the numbers. But on the fundamental theorem, which is this right now on the top, you've got to integrate, which gives you t cubed over 3 minus 2t squared plus t, right? From 2 to 8. And you've got to get disciplined about showing your work. Remember, I have so many people that are just like writing crap on their page so they can get an answer down. You're not getting points that way. Now, in a multiple choice question on the AP test, yeah, you can get points that way. But on my test, I'm grading every one like it's a free response question. So I'm giving you a point for the setup, maybe a point for the remembering the denominator, a point for the integral in this form, right? And then showing me you know the first fundamental theorem, which says plug an 8 in. What's 8 cubed? 512, right? And then 8 squared times 2, 128 plus an 8. And then you plug the 2 in, right? Plug the 2 in and divide all that by 6. And then whatever that cleans up to be. And if you had your calculator, all I would need to see is that and an answer. That's it. None of this junk. Remember, if you have a calculator, use it. Right? All right, now I'm throwing you a curveball here. Determine the average velocity on the interval if the position is given by that. Now think, how do you find average velocity? I'm still thinking this formula. Average velocity is what? Well, hold on, answer this question. Okay, you are answering it. Average velocity using the integral formula is still the integral of the velocity dt, right? But I don't have it. Now you could take position and do what? And take the derivative of it and shove it in there? But what are you going to be doing when you integrate?
Undoing the work.
Undoing that. Like if you, I'm going to say it again if your brain's spinning. You could take position, take the derivative of position, and you get velocity. So you could do that if you want. But then literally, if I take this and plug it in there for velocity, which listen, you can do this if you want. What happens when you integrate that velocity? You're getting right back to this position, aren't you? So why don't you just think, wait, if I integrate the velocity function, I get the position function from 2 to 8, right? Right? Well, then just find x of 8 minus x of 2. And I don't even need that. So if you understand this average velocity and kind of how it works, it just depends on what I give you. So in this case, I didn't even need to take a derivative or an integral. I just was given something different. I can just plug the 8 in there and get 64 minus 32 plus 1. And I can plug the 2 in there and get 4 minus 8 plus 1 and divide it all by 6. Y'all seeing that? But anyway, make sure you know this average blah, 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 whatever formula really well. We're going to go over a bunch of examples today, but they're not going to be really word problems. AP loves to ask word problems like this. So sometimes there's a relationship between the two functions, but if I say average velocity, go ahead and write it down. Write the formula down with the V in it. And then if you're thinking to yourself, wait, when I integrate that V, I get position, and I have the position function. Great, you just saved yourself the trouble of having to take a derivative or whatever. Tracking?
Tracking.
All right. Okay, jump to, what is it called? Module 4. I think we're on page 129. Let's take a look at just some random problems. Most of these are all AP questions that occurred, and I'm going to be throwing all kinds of different stuff at you over the next couple days because we got to get you ready for your test Thursday, Friday, right? All right, 2-day test. So all these problems could totally be test questions. So the first one, the ddx of the integral from 0 to x squared of sine of t cubed dt. Now, I know it's multiple choice. On the AP test, you just circle an answer, you get your point. On my big test at the end of the year, that's true. But on my test right now, I'm going to point these out. So this might be like a 3-point problem. So what do you see? What is screaming at you right here? What can you hear? I can hear. Second fundamental theorem. All right, yelling at me in the background. So what does the second fundamental theorem say?
Just plug in the.
So basically the ddx and the integral are going to cancel each other, right? So I'm not actually going to have to integrate at all. And the 0, based on the proof I showed you, it ends up being completely irrelevant, doesn't it? So all I have to do is 2 things. I need to see 2 things on your paper, which is take that, plug it in. So I get sine of x squared cubed. So sine of the x squared cubed, there's no more dt anymore, that's gone, right? If the integral's gone, the dt is gone. I keep seeing the dt, people keep writing it, or they integrate it, or they keep the integral, they're doing all this stuff. Make sure you have good form. But what am I missing if I just write that?
You're missing the.
And by the way, that'll be an answer, of course. I forgot to do what? Take the derivative of that, which is 2x, and probably the 2x, you're going to see it up front. All right, so don't get sucked in by this. Make sure you're patient. And right now, the AP questions are A, B, C, D, but older ones from like 2018 on back were A, B, C, D, E. So that's why these have 5 choices. Now they only have 4. All right, so great, E. Look at number 2. And number 2 has a little curveball in there. I remember missing these early on when I was taking AP. I would read it and I would get really excited. I'd miss the question. I just wouldn't read it completely. Now, this is a calculator problem. So you get your calculators out. Let's take a look at this. And this is the kind of stuff they sneak on you. All right, you just got to be careful. For some of you, you're going to go, oh, that wouldn't have snuck on me. Snuck up on me, but sometimes they do. So just be careful, but it is a question like I would ask. So it says the rate of change of the altitude is given by this function. And guys, get this in your brain. When I see rate and then I ask for a amount, what do you do to go from rate to amount? Integrate. Okay, so I'm giving you this rate from 0 to 8 seconds, or whatever it's talking about, minutes, whatever. Which of the following expressions gives the change in the altitude of the balloon? And that's where I quit reading initially. Right? Because if I quit reading right there, I'm saying, oh, well, if I'm giving you a rate that it's changing, and I want the amount of change, which is what it's saying, right? The actual change in the altitude, I would integrate the rate from 0 to 8 to get the amount. And of course, boom, there it is, B. But that's not what it said. It said, what is the rate of change in the altitude during the time that the altitude was decreasing? Now, how do I know when the altitude is decreasing?
Just plug some numbers into your, or no, find where the derivative is 0. When R is negative.
Bam! When the R is negative. Think about it. This is a rate at which it's changing, right? If the rate's positive, then what's it doing? Getting bigger. If the rate's negative, think about velocity. The velocity is positive. The velocity is negative. What's a rate, right? Rate of change in the altitude essentially is a velocity, right? So if the rate's positive, it's getting bigger. If the rate's negative, it's getting smaller. They want to know during the time when the altitude is decreasing. If the altitude's decreasing, my rate was negative. So how do I find out where that rate is negative? You got to calculate. Literally graph it. So if I graph it, I can look and see where it's below this is just a rate function. I can look and see where the rate function's negative. Are you following me? And just find out where those x-intercepts are. Now, for those of you who said set it equal to 0, your thinking's good, but I'm not going to be able to solve that setting it equal to 0. That's why it's in the calculator section. I can't do it. I don't have the algebra to do it. And there's no time for checking possible rational roots and synthetic division. The answers are going to be terrible decimals. Okay? So just graph it. And when you graph that function, you can see it dip down, and it happens to cross where? At 1.572. And you really don't even actually have to find these values. You can eyeball them. Like if you graphed this right here, and this was 0, and this was 10, and you see all your tick marks, 1, 2, 3, 4, 5, you can see it crossing right here like that, and then crossing again like right there, whatever. You can see it where it's negative there and there, and there's really no other options, right? There's a 1.572, there's a 3.5. There's really no other, it's not crossing at 2.6 or 0 and 8. So it's either A or D, but we know that when we integrate a rate, we get an amount. Now, this person that would have chosen D, they got confused, right? They looked at R like it was an amount, and they said, oh, if it's an amount, I need to take the derivative and make it a rate, right? Kind of like you would do with position velocity, make it a rate, but it already was a rate. So I integrate the rate from there to there, and that finds the change in the altitude when it was decreasing. But don't get sucked in by B. I almost remember missing this one, or almost exactly like it, because I just was working through quickly, and I went, gives the rate of change in the altitude of the balloon, and I quit reading. But it's when the altitude's decreasing. So there's a little bit going on in that, right? And the more you see these, the better off you're going to be. So A. All right, look at this next one. A particle moves along the x-axis so that at any time that's positive, the acceleration is given by a of t. So you've got the acceleration function. And by the way, have you noticed that they are giving you equations that are just a little bit ugly from time to time? So if it's a calculator problem, again, remember you're holding your calculator. Use it, okay? So that you got the acceleration. It says the velocity of the particle is 2 when the t is 1. And the velocity of the particle, it says then the velocity of the particle at time 2 is what? So what are we given here? We're given an acceleration, and I'm given the velocity of the particle is equal to 2 at time 1. Give me an expression that means that. V of 1 equals 2. Are y'all able to see that? The velocity at time 1 is 2. Okay? Then it says the velocity at time 2 is what? So this is saying V of 2 is, I don't know. Now, let me ask you a question. How can you use together acceleration and velocity like this? So if I integrate this velocity, this acceleration, right? If I integrate that from, and what times do you want to use?
2 and 1.
Why not? That's the ones that are given. From 1 to 2, what do I get?
V at B minus V at A, which is V at 2 minus V at 1.
So I get technically V of t from 1 to 2, which is just what? V2 minus V1. And you can really skip this part that's in the cloud right here. If you see that, you can jump straight to the FTC. Are you seeing this? Now, George, I think it was, when we were initially talking about fundamental theorem, we were doing problems like this, right? And the question was V2. And he's like, well, if you want V2, why don't you just plug 2 into the acceleration function? Can you do that here?
Yes.
Can you?
I don't see why not.
Because I have V1 as this. If I want V2, let's take a look and see.
You can't because it doesn't start at 0.
Well, let's take a look. Right here, if I find the acceleration using my calculator, got to be honest with you, I probably would have just jumped right to that. If I find my formula, my value using my calculator, I would say the integral, and I'm going to go straight to my integral function. There's a couple ways to get there. Hopefully you're good on that, right? I'm going to type in 1 and 2, 1, 2, and I'm going to type in my acceleration function. So the natural log 1 plus 2 to the, and you can use t or x, but whatever you use, make sure you use the same variable twice. So I'm literally calculating that integral, and I get 1.346, right? And that's equal to V2, which I don't know, minus V1, which is 2. So it looks like I could just add 2 to that and get 3.346, and you can see that right here. Except if it was my test, make sure you write V of 2 equals 3.346 here. You'd be showing your steps. Is there another way I could set this up, by the way? Have the V1 on the other side. So if I just start with this and not have it at all there, right? I'm basically saying, hey, if I want to find the ending velocity at time 2, I need the initial velocity at time 1 plus the change in the velocity. So I can totally do it this way also, right? Now, let's check it. If I plug 2 just straight into that acceleration function, what do I get? ln of 1 plus 2 raised to the 2 power, so I guess ln 5. And I get what? A different number. Are you with me on that? Be careful. All right, you've got a problem. Let's just find that value right there, add the 2 to it, and we're good. And again, on an AP test, you would just be picking the answer. Tons of people will pick one. Well, actually, they didn't even have it as an option. I don't know why. A lot of people pick 1.346 on this. Or, let me check this value. I bet they have the one, if it's a 0 at the bottom. 2.233. No, they didn't. They had some pretty lame options here. But anyway, are y'all with me? All right, check out number 2. These are all AP questions, guys. Let G be this function on which of the following intervals is G decreasing. This is G. Where is it decreasing? Now, somebody said where G prime is what?
Oh, it's not necessary. Well,
It's decreasing where the derivative of G would be what? negative. Now, I have people every year that just graph G. If I graph G and just see where it's going down, right? I just look at the G function and see what's decreasing. Could I get this? Now yes, that's using pre-calc. I mean, yes, you got to type in that, you got a calculator, so you technically could do that. But AP a lot of times will make the function where you can't find it. Like you go to graph it and you're like, I can't see where this thing ends up. Like it's so far down or so far up. You're like, what the heck? It's not in my window. And it makes you scramble to try to find it. But if I just find out where it's negative, sometimes I have a better bet where the derivative actually is negative. But I can graph that G function if I want. Or I can take the derivative of it and it ends up being a little bit better looking. What is the derivative of G right here?
Sine of x squared.
So the derivative of G would just me being ddxing both sides. So really, the derivative of G is just me plugging the x in, taking the derivative of x, which doesn't do anything, and saying, when is that less than 0?
So you just graph that.
I'm going to show you both. So I'm just going to graph y equals that and see where that's negative. So if I go and graph that, I end up getting something that looks like this. If I'm graphing this, I get something it looks something like this. It 2.5-ish. But it has a weird little graph like that looking at this. Are you seeing that? And I'm using the second fundamental theorem, and it wasn't a big deal. And you can go, oh, so when was the derivative less than 0? On the interval from 1.772 to 2.507. And again, you can graph it. You really didn't even have to actually find the zeros, because it wasn't like there was an option for 1.7 or 1.6 or 1.5. That's the only one that was even close, right? So sometimes you can just eyeball it. You don't have to trouble yourself with finding the actual zeros there. Now, I'm going to graph this thing and show it to you. I have absolutely no idea what I'm going to get, but I think it's maybe worth it. I want you to really get better with your calculator. And I got to be honest with you, there are times when you're 84. Who has an 84 in here? There are times when your 84 is not, it doesn't have a big brain. I kind of think of it like there's deer, inspires like a deer, and then the 84 is kind of like a squirrel. Okay? Listen, I've heard of deers just running into the side of a car. Like I have a friend of mine who deer ran into the side of his car. He's driving down 119, and all of a sudden, wham, into the side window, cracked his window. And of course, the deer, I guess it was just on a full sprint, literally, ran into the side of it as he's driving down the road. But a squirrel, man, their brain's like that big. Those guys, it's like they're trying to run into your car, you know? So anyway, but sometimes your calculator has limited brain capacity, and you go to hit graph, and that little thing just spins at the top. Or you see the graph doing like this. And you're like, man, I'm going to be here 10 minutes. I punched one in once, 20 minutes. If I skipped the calculus. So if you skip the calculus on this problem, and you say, all right, this is me skipping the calculus. Man, I'm just going to find out where the function's decreasing. So I'm going to delete this out. Ooh, I'm in totally the wrong mode here. Hold on. Delete, yes, menu, graph entry, function, menu. My menu, I'm going from what? -1 to 3, -1. By the way, this is always a good idea to go ahead and make your window where you can see stuff. And I'm just going to go -10 to 10 on the Y. Okay, so here we go. Menu, tab, and I'm typing in the integral. I'm typing in the integral from 0 to x of sine of t squared dt. And if you're wondering, man, how does it graph it? sorry, how does it graph it with t's in there? Well, it really doesn't, because if you're actually integrating, remember, you're doing the integral, but then you're plugging the x in. So it ends up having x's. Sorry. So I'm going to graph this and see if I can see where it's decreasing. Graph. Oh, I know why that happened. Menu, settings, radians. Okay. It's kind of slow, right? I gotta tell you, if this thing's graphing that slow, try it on your 84. Okay? That's still thinking, still putting it together. Okay. So where is it decreasing? This is 3. Looks like it peaks at about what?
1.7.
And that's 2, maybe at about 1.7. It starts going down to about 2 point something, and then starts going back up. You might even be able to see it a little bit better if you changed your window to like the Y's from like, I don't know, -2 to 2.
Can you just do some?
Well, remember the graph goes forever, for left and right forever. So what's it fitting on?
I mean, usually when I do it, it just fits to the most curvy bits of the graph.
Usually, well, if you want to go with usually, you can. What's that commercial with on the Super Bowl?
Colgate.
No, what was it like the? Who's the?
You want to go with slide power?
You want to go with pretty sure or
Oh, the JD Power Dependability Award.
no? It's the one with chat. What is it? Who's the guy from 30 Rock? The funny.
Priceline.
Y'all didn't see these?
I know.
What's the guy's name? Tracy Morgan? And he's down there and he goes, "Do you want to go with?"
Those for insurance.
It's for for insurance, and they're like, "Oh, we want to go with pretty sure." It's like, "Hey, can we jump over this bridge?" I'm pretty sure. It's really funny. There were 2 of them they showed. It was the only one time I laughed. I was like, "Okay, those are funny." So to me, I don't want to go with pretty sure. I want to go with, hey, I'm going to set the window based on what they gave me. Because if it gives me a bad window, I'm going to pick maybe a different decreasing part. Are y'all seeing this? So I could have done this, but how long did it take on the 84? Anybody plug in? It's probably still spinning.
Oh, I tried.
Okay?
It literally was like.
Yeah, so AP, remember, a lot of these problems, especially this day and age, there wasn't even a Spire around in 2003. So everybody had the 84, so they made these problems to hurt you if you didn't use calculus. And man, all I got to do now to make it hurt, that was just a sine something squared. What if I made the natural log of the sine of something cubed to the 4? All I got to do is throw an extra function in there and really stick it to you, and it'll be taking forever to graph those things. But they just wanted you to actually use calculus in the fundamental theorem. So, but you could still get around it with an Inspire and know that, because sometimes you might get stuck. There might be more than one way to skin a cat, right? All right, so check this out. All right, so moving on to these. I'm going to do some average value problems with you. I need to watch the clock because there's a couple I want to really make sure I get to. Okay, so these first 3 non-calculator problems. I'm giving you a function. I want the average value of f. Help me out. Just set them up for me. And but I want to talk about part B, because part B we haven't addressed yet. I mentioned it, but not really officially addressed. So how do you find the average value of f if I give you f?
You do the
Guide my hand with words.
the integral of from 0 to 2 of the function of f
Which is x squared plus 1.
over
dx.
Over f, yeah, over
2 minus 0, which is 2. And I'm being excessive writing 2 minus 0, but whatever. You're fine with 2. Now, don't just plug 2 in and 0 in. Integrate it. What's the integral of that?
that would be x
Plus x, line 0 to 2. Notice the dx is gone, the integral's gone when I integrate. Over 2 again. And then what happens when I plug the 2 in? 8/3 plus 2 minus 0/3 plus 0. That was nice. All of that over 2. right?
Yup.
And what's 8/3 plus 2? 14/3. And what's 14/3 divided by 2? 14/6, which is 7/3. And if I don't have that 0, though, it's easy to see this better. What could you multiply the top and the bottom by to make this a little easier? What if I multiply the top and the bottom by 3 and distribute it in? Don't I get 8 plus 6 over 6, which is 14/6 or 7/3? And then you don't have to think about fractions, but whatever, do the math. Now, this is what right here? So this is that f of c. This is the actual average value, the y value that you get. That's what you just found. Of all the y values on this curve, you just found the average of all of them on the interval from 0 to 2. So how do I find the x value, which is the c, that's guaranteed by it? How do I find, remember we did that little thing we said, at what value of c is the height such that the area of the rectangle is the area of the whole curve?
You just plug in 7/3.
Close. You plug in 7/3 for the y.
Yes.
So you just go back and you plug 7/3 in for the y. Now on this, it's pretty easy to solve for that, right? But remember, you're not always going to have a function you can solve for. And if you're sitting there holding your calculator, what can I do with my calculator if I can't solve?
Plug it in.
I can move it all to one side and graph it to solve, right? Don't forget that about your calculator. If I was unable to do this, like say that was x to the 5th plus x, and I'm like, I can't set that equal to 0, and so I don't have the algebra to do that, right? Remember, I can move everything to one side, graph it, and find the zeros that way. And remember, the only zeros I'm looking for are the interval from 0 to 2.
Wait,
But this, I'm sorry?
How would you graph it if you?
Like if I was not able to do this manually, I would subtract that 7/3, which would give me what, minus 7/3. I'd have a negative 4/3. And then I would say, I'm going to graph that function and then find where y was 0, which are the zeros. But in this case, I don't need to do that, right? I'm going to subtract a 1 and then root it, and I get x equals plus or minus 2 over root 3. Now, which ones do I keep, or do I keep both, or do I keep any?
For only the ones on 0 to 2.
Only on that interval. So the negative one is totally out. And then I can keep that because root 3 is what, about 1.7? So 2 over root 3, 2 divided by 1.7 is what, 1-ish? That's on that interval. So I'm good. And I don't need to rationalize. If I want to, great, but AP doesn't care. All right, what about number 3? Let acceleration of the function, let A be the acceleration. So I've got that from 0 to 5. It says the average acceleration. Average blah. How do I find the average blah? I integrate the blah. So I integrate it from 0 to 5 over 5 minus 0. And that finds the average acceleration. It finds that average acceleration. Now, if I didn't have the acceleration function, but instead I had the velocity function, I can't plug velocity in there, right? But I could integrate acceleration gives me velocity. I could still use that velocity function. But I do have the acceleration function. It's right there. So I'm going to integrate it. What do I get?
First one is
3x cubed over 3, which is x cubed.
x cubed plus x squared.
Plus x squared over 2. And all of that from 0 to 5 over 5. So we're plugging the 5 in. So 125 plus 25 halves. We're plugging the 0 in. Minus 0 plus 0. And all of that's over a 5. And I'm on my way. I'll save you the trouble. 55 halves. Well, what's the other question? find the average acceleration of the function a different way. How would I find the average acceleration a different way? Forget this. Is there any other way to find average acceleration?
Main sums.
Let me give you a hint.
The acceleration.
What if this is velocity? How can I find average acceleration? Well, if I integrate acceleration, what am I really getting?
You're finding v at v minus v at a.
That's right. Did y'all hear that?
But isn't that the same way?
Yeah. So if I integrate acceleration, I get velocity, right? So I'm going v of b minus v of a over b minus a. But it's not really different. It just allows me to use a velocity function should I be given a velocity. Right? If I have the velocity function, the change in velocity over change in time, that is the average of the accelerations. Right? Because that's what happens when I integrate acceleration. So I would just say this. This is how I find average acceleration. But that's on your sheet from yesterday too. But yes, it's really not that different. I'm just integrating acceleration to get that. All right, little practice with this. What about number 4? We're just going to write them out. I'm not going to do a lot of simplifying. What do I get here?
I just plug the 3x into the function.
So do I integrate?
No.
Because the ddx and the integral cancel. What do I do with this 1? Toss it. So I plug the 3x in, and I get 3x quantity squared, which is 9x squared. I plug and that's it, minus 1. Am I done? Times the derivative of that, I put the 3 out front. And for the love, don't square root 9x squared minus 1 and get 3x minus 1. It doesn't work, okay, when you have a sum or a product. What about this?
Same thing, just put a negative.
Okay, so when the 3's up top, I got to start with the negative. I'm still going to ignore the 3. I'm still going to ignore the ddx of the integral. And I'm plugging the x in, x sine x, and the derivative of x is 1. So I'd be finished there. And then in the bottom,
Same thing.
same thing, cosine of x squared times a 2x, right? And again, you're ignoring the pi over 2 because that's a constant. You're ignoring the ddx of the integral. I got till when? 10:40? Okay, so a couple I wanted to really do here. I'm just going to jump to number 9 so I don't miss it. All right, guys, this problem can be hard or easy. It's pretend this is a calculator problem. And again, you've got to start freeing your brain up to use your calculator and trust that it can actually do a lot of stuff. All right, so right here, find the numbers b such that the average value of f on the interval from 0 to b is equal to 3. Now let's just start writing out what we have. The average value of f, how would I write that? The integral of f from 0 to b over b minus 0, right, is equal to 3. Can you use your calculator to solve this?
Sure, just move the 3 over.
Graph it. Like, you gotta open up your brain. People think, well, no, I don't. I can't do that. And listen, you can't type this in your calculator and get an answer. There's a variable in there. But I can graph all kinds of stuff. Now, you do have to make sure your calculator can think right, okay? Remember, your calculator is graphing in y's and x's, right? Not d's and a's and stuff like that. So if I'm a graph in y's and x's, what do I put? I only need to put right here and here.
Is x.
I'm going to put x's because I'm going to be graphing y equals all this junk. So here's what I'm going to do. I might set it up like this, but if I have my graphing calculator, I've done a setup. I'm going to change this b. I'm going to let b be x, And I don't have to do this, but if you're really having good form, you don't want these variables in your function to match this, because you want to be plugging in for something different. But I checked it last night on your calculator, it works. So you could totally use this. But if you're really doing good form, you would want to say, hey, I'm going to make these t's. So as I integrate, I'm plugging the x in for the t, and I end up having x's. Now, literally, I am going to take this, move everything to one side. The easiest way I need to do that, I can just subtract the 3 from the other side. And then I'm going to graph this. I'm going to say, okay, if it's equal to 0 now, I'm going to replace 0 with y, right? I'm just going to get rid of the 0, and I'm going to graph this and find the zeros. And by the way, I have no idea what b is, but I do know I started with a 0. So when I set my window up, I don't know. I might need to go from like 0 to 20 or 0 to 100, or at least look at the answers if it was multiple choice. So check this out. Here we go. I'm going to show you what I'm going to do here.
How do you clear all stored variables?
If you want to clear everything you've stored, go to the scratch pad and go Menu, Actions, Clear A to Z. Yep. And I would have to look at the 84 to figure out how to do that. Math, no, mode. Store, reclaim. I don't know. I'd have to. I know you can hit reset in the back. Hit the little dot on the back and with a paper clip, and I know that'll do it with the 84. But other than that, I'm not quite sure. So here we go. I am going to graph. This thing's struggling. That function was so ugly. Okay, so menu, window. I'm going to go from 0 out to, I don't know, maybe go 20. All right, and then I'm going to go tab, and I'm going to graph that ugly thing. So here we go, fraction button. Integral from 0 to x of 2 plus 7t minus t squared. 2 plus 7, look, you can even use x. 7x minus x squared, but it would be better to use a different variable, I think, at least on the 84, on this Inspire, all over x minus 0. And I'm going to subtract 3. So I'm going to graph this. And it might take a second, but I actually did this on the 84, and the 84 actually graphed it okay.
It didn't take long.
No, it didn't on the 84. So when I do that, look, you can see it what? Crossing there, which ends up being 0.294, and you see it crossing there, which ended up being 10.26. Now, how would I find those values? Well, I got to go menu, analyze the zeros, or if you have the 84, second, calculate the 0, and go lower bound. I don't know, left of that would be a 0, right of that would be a 1. So there's your first point, 0.294, if you round, right? And then I would go, all right, menu, analyze the graph, find the 0. I don't know, lower bound looks like 5, upper bound looks like 15, and it spits out 10.206. And I didn't have to do any of the algebra. Every year I give a problem like this, and you know what I see? I see this setup and people stop, or I see this, okay, I need to find the integral, and they go, and again, I'm gonna go put the x back in there. Like, this is what I'll see. And there's just no points for it. Here's your b. I will see 2x plus 7x squared over 2 minus x cubed over 3 from 0 to b over b. All right, now I got to plug the b in. 2b plus 7b squared over 2 minus b cubed over 3 minus, plug the 0 in. That's at least a gift. 0 plus 0 minus 0. All of that over b. I'm like, okay, this cancels. All right, the b, if I divided it into each part, would give me 2 plus 7b over 2 minus b squared over 3. And that's my function. That's my average what do we say, average acceleration, or what are we doing on this problem? It's just a function. So that's just my special f. How do I solve for that now? What do you end up doing? You still end up graphing, right? You still end up setting that equal to to y, graphing it, and you get the same two values. Because that's the way I did it on my key. And I've taught this for 8 years, and it took me till last night where I'm like, why am I doing this? Okay, if you can get it in your head when you have your calculator, guys, the second you get into an equation, if you need to solve it, move everything to one side, graph it, find the zeros. Literally, any single time. Done. So nice. All right, let's try it on this next one. Find the value of C guaranteed by the mean value theorem for integrals. Actually, let's do number 10. We're running out of time. In a certain city, the temperature in degrees Fahrenheit, T hours after 9 a.m. What does that mean? That means T hours after. So what if T was 1? What would that mean? 10. Well, if T is 0. 9. So do you get that they're saying from 9 a.m. to 9 p.m. is saying T would be what? 0 to 12. Do y'all see that? That's annoying, but they do that kind of stuff all the time. So hours after 9 would be, okay, I'm starting at 9. That's my 0. T would start then. You got to be able to lock in on stuff like that. If you go 9 to 9, you're going to miss everything about this. I mean, you might get some points from me, but you'll get no point on a real multiple choice question. All right, so if that's T, right, yeah.
So if it says to find the average temperature during the time period of 9 a.m. to 9 p.m., are we just ignoring half the hours and starting? Or
I'm sorry?
never mind.
Okay. All right, so I'm finding average temperature, and this is temperature. So what do I do for average temp? I integrate big T of T from 0 to 12 over 12 minus 0, which is 12. That's all I got to write on my paper. Literally, that is all I have to write on my paper. And you're going to type the integral of this function. I don't even have to write that function down. It's already been defined, right? But I do have to enter it in my calculator. And when I enter that in my calculator, the top part ends up giving me 706 if you did not enter it in as a fraction. 0.952 blah, blah, blah over 12, which eventually gives you 58.913. But I would enter it as a big fraction and it'll just spit out 58.913. These are AP questions like this. They're just not hard. I don't know what it is about average value that makes people miss it or forget to divide by 12, whatever. But if you just get that formula down, man, those are the freebies. So easy to grab. All right. How'd that take-home quiz go?
It was pretty easy.
It was really good once I actually did it.
Yeah, funny how that is. Anybody learn anything new? I'll post the key for that today. Go back and check that for your sake. All right?
Aye, Captain.
Yeah, remind me more. I'll hand them back to you, at the very minimum. And post that key too. Actually, I have them right here. You hear us? Make sure you grab this for me when I, Daniel. Sarah Parker. Hey, grab these for me if you gave me one yesterday. Izzy. I put it in out of 14, so some of you, when you missed some stuff, actually got some bonus. Like coal. Yeah, because it went. And somebody gave me one that didn't give me a name. Actually did well on it. Well.
That's right.
See you.
Very kind of Steve.
Yeah, what is that?
The national one.
Yes. I'll get that in. What's up, man?
I didn't, Sam was definitely also supportive of it. I wouldn't worry. I swear, all my picks came up with easy. You're talking about 50? Yeah. It's like 5,000 words. Even a week.
Yeah, we have to do.
Yeah, that's. The annotated gives we all.
No one wants to.
It's just rephrasing what we already have. Ben did nothing. I was like, what is he doing? Maybe he's doing something. Maybe he's getting more links. He's just playing the snake.
Oh, we haven't.
Wait, he has to do.
Is
that in English?
Yeah.
What do we have to do in English?
Everything.
Have you finished your essay? If you're screwed, because you also have to do a 1,200 word, like bibliography about all of your sources.
No, we have less than 4 people.
You have to talk about at least 8 of your sources, each of them has to be at least 150 words. But you have like 9 questions to answer for each one, so it's probably gonna be more like 300. Just do tomorrow.
And like she always puts me in this group with like Will. So
Isaac.
in her little star, my head in it.
It's just, there's only 5 questions. You just said it.
Yeah, but it's in the pod, I'm like find one thing, like report on the devices. And then like 8th grade.
Where are you guys?
Good.
Right. All right, so I got somebody who gave me a page 375, but did not just get it back. So if you handed B page 375, but you didn't just get back page 375 and 380, tell me because I have a who are you on?
I didn't get it back.
Is that you?
No, that's not.
Anybody?
I probably just forgot.
375, 380. I haven't given you credit. You probably want credit. Really? $375? It's got to be somebody's. Did anybody just not get 375 back who handed it in? I can't really call your name out if I see a 0. That's you? I could call you now, but I'm not going to. Anybody else want to check?
I don't have that, bro.
I think I see it.
That's not you? No, that's not you. All right, nobody wants to just take a peek? It drops your average like a half a point. Every homework you miss by the end of it, maybe more sometimes. Really?
Yeah.
Can't do it. It's right to Privacy Act. Technically, I'm not even allowed to go. Biff here made 100 on the test. That technically, that's their privacy. I can't share their grades. If you still have teachers that do that, they're literally breaking the law. Or if you swap papers and grade, oh, massive breach of privacy. That prison awaits.
What an unethical teaching style.
Yeah.
All right. Well, I may or may not text you and say, hey, check this out. But if you want to come look, it's sitting right here later. I'd hate to not give you credit. Huh. Strange. All right. How are we feeling about this? Anybody got any particular questions? I mean, I have another day of random questions I can throw up here, but it's not going to differ a whole lot from yesterday. In a normal world, I would call you guys out, I would put them up on the board and say, go get them. And people would just walk up there and do them. And my hope would honestly be that they make some mistakes, because those usually the mistakes people make. And, you know, not to humiliate anybody, but to go, oh, I see that. Make sure you're careful about that. But I can't really do that because of rules of sharing pens and crap. Yeah.
I had a question on the review, page 62.
On the review.
62, number 10, review.
All right, check it out. So this one, fourth degree equation?
Yeah, so for that one, I just need to know, so you just flip them, right? So you do 3 plus I over 2 multiplied by 3 minus I over 2?
Sort of. Now remember, these are roots.
You got the X there.
So first of all, that's in terrible form. All right, that's not even A plus BI form, but I'm just messing with you. But yes, if it's a fourth degree equation, that means it has to be x to the fourth, right? But I've only given you 2 roots. The other 2 roots could be anything. Wait, not if they're integral coefficients. If there's integral coefficients or real coefficients, which what integers are, then these would have to occur in conjugate pairs. And conjugate pairs means that you just change the sign of the imaginary part. So that's a root, as is 3 plus I over 2, as is 4i. Now these are roots, not factors. So to change them into factors, I have 2 options. One, I could go x minus that. So I could go x minus that, x minus that, x minus that, x minus that, and foil the ever-living crap out of everything. I can do that. Or I could do what? The sum and product rule, which gets me at least to the quadratic parts. That'll get me 2 big factors, might save me a little bit. So let's see. To do the sum and product rule, I would have to find the sum times x, the product. That could get me to this, and then I could do the same thing here, x squared minus the sum x plus the product. Well, here it's easy. What's the sum of those two? Nothing. That 0 makes all that go away, which means in that case, I really don't even need the minus 0x. I can go straight to the, right, minus 0x is gone. I can go straight to the product. And what's the product?
16.
Negative 16i squared, which is positive 16, so plus 16. But honestly, how hard would that have been if by just saying x minus that, and foiling? You would have gotten that anyway. The real advantage you get from the sum and product rule is here. So what's the sum? Now, it's a little ugly, but what would happen if you added those? You would keep the denominator, and you'd go 3 plus I plus 3 minus I. The i's cancel, and you get 6 halves, which is 3. Bam. And then the product, you're going to have to FOIL the numerators, and the denominators give you what? 4. So let's FOIL out the numerators. 9. Now what happens to the outside, the inside when you're multiplying conjugates? They go away, right? So positive, negative 3i, positive 3i cancels, and then the last term would be negative I squared, which is positive 1. So I end up with 10 fourths, which is 5 halves. So there is my first factor. There is my second factor. Set them equal to 0 and multiply them all the way out. Now, if I'm going to end up with integral coefficients, that 5 halves is not doing me any favors, is it? In fact, it's going to put fractions in at least 3 places. Can you clean this up right now before you even get started? What could you do? So I could multiply this by a 2, this side and that side. And then I don't multiply, distribute the 2 into both multiples, both fractions, do I? No, I just do this one because it's just right there. It'd be like me going 2 times 5 times 10. I don't multiply 2 into the 5 and the 10, right? Because it's all a product. I just go 2 times 5 is 10, and then I multiply. So right here, I end up getting 2x squared minus 6x plus 5. And at this point, I am going to have to suck it up and multiply, aren't I? Right? So it's still a little annoying, but not as bad if I knew the sum and product rule, I think. So if I multiply this out, I'm going to do the math over here. I'm going to multiply x squared by everything. 2x to the 4th minus 6x cubed plus 5x squared. And then I'm going to multiply 16 by everything. 32x squared, that goes right here, minus 96x plus 80. So not a whole lot lined up on that one because it wasn't a trinomial. A little bit did. Y'all see an error? If you see an error, throw it out. So I end up with 2x to the 4th minus 6x cubed plus 37x squared minus 96x plus 80. And again, don't forget to set it equal to 0 because it said equation. Right? Anybody else on anything on the homework? And if you don't, and you feel confident, you're welcome to do your thing and review. I never used to talk during review days. People come in, they're like, it's review day, yeah, and they just start working.
Could you do number 3 on the review, just because I
The one we did last night? Oh, this review right here?
Yeah, I just forgot how to do the jointly.
Okay, so jointly means directly to 2 things. So I'm going to do the setup, and then you can look at the rest.
The joint is directly.
Yeah, it's like jointly would be directly twice. So if it said x inversely with y, so x you'd multiply by the y, but it's jointly to the w and the z. So it's jointly would be like directly, so you divide jointly to the w and the z.
Oh, okay.
It's not just under the Y.
Sorry?
It's under everything, not just the Y.
It's under everything because the
Multiply the y by x.
yeah, you're multiplying the y by the x because inversely. You're dividing by the w and z because of jointly. And then because this is a proportion, this right here would be your constant of proportionality. That constant doesn't change. So it doesn't matter whether I'm using x1, y1, w1, z1, or x2, y2, w2, z2, doesn't matter. So if I can just set up a fraction like that and start entering stuff. So when x is 4 and y is 6, w is 8 and z is 10, then what is y when x is 10 and w is 12 and z is 4? And you're solving for y. And do you remember my slide rule? What's the slide rule say I can do if I have a fraction equal to a fraction? I can take this 10 and slide it down. Take the 12 and the 4, slide them up. And there's your y. All I got to do is multiply. And by the way, I don't know if it's an advantage for you to try to multiply all that together and get two giant numbers. You want to start canceling stuff, right? So look for ways you can cancel, like, all right, I can cancel that 4 with that 8, leaving me a 2. I can cancel that 2 with that 6, leaving me a 3. I can cancel 2 out of that 12, 2 out of that 10, another 2 out of that 6, 2 out of that other 10, and I'm left with a 25 on the bottom, and a 3, and a 4, and a 3 on the top. So what does that end up giving me? 36/25. And if I'm really careful, I can see that. And as you're canceling, don't cancel so much that I can't see what you're doing or there's nothing to grade. Y'all seeing that? And remember, I could say the square of x is inverse. If I say the square of x, what do I write? X squared. If I say the square root of y, square root of y. If I say the cube of x, x cubed. The cube root of y, cube root y. So look for the words. Make sure you're careful with stuff like that. And make sure your setup's good. I'm going to look for your setup. I'm going to look that you plug the numbers in, and then I'm going to look for an answer.
You do number 9 on page 58. I just don't really understand Descartes' rule.
Okay, so Descartes' rule, again, not the best rule on the planet. It's not like it's going to be life-changing for most of your work. Honestly, if I was trying to solve a problem like this, this is not even equal to, yeah, it's equal to 0. If I was looking at it and I didn't see all positives or all negatives or alternating, I probably wouldn't even bother. But it tells you to do it. So I'm going to do 3 things. I'm going to find the number of possible positives, the number of possible negatives, and the number of possible imaginaries. And to do that, I'm going to check signs changing. So the first thing I do is just look at the original problem. And as I move from left to right, how many times do the signs switch from plus to minus? Well, plus to plus isn't a switch. Neither is plus to plus, but plus to minus is. Minus to plus is. Plus to minus is. Minus to minus is not. And minus to minus is not. So I counted 3 changes. So I go to the number of positives, and I say it could be not 3, 2, 1, or 0, but 3 or 1. And if you're really wondering why, again, because imaginaries occur in pairs, if there's going to be 3 positives, I can't take one of those positives away and make an imaginary, because imaginaries would come in pair. I'd have to take 2 of them away, which would drop it down by 2. So that's why I dropped down by 2. And don't go 3, 1, 0. 1 to 0 is not dropping down 2, is it? And if that really bothers you, again, I have not done any research on Descartes' thinking. I haven't read his memoirs. Descartes, the rule. I haven't read the book or anything. I don't really know what his process was. I just know the rule. And again, I don't value it a lot. It's just something that I'm supposed to talk about. And it does occasionally rear its head, and you need to know it.
So if you got 4, would you do 4, 2, 0?
4, 2, 0. Evens will go to 0, odds will go to 1. Now, for the next step, this is technically me looking at the function f of x. So the next step says, now look at the function f of negative x. Now, I can actually figure out f of negative x, which literally means plug a negative x in there and simplify, and then do your trick again. That's a lot of work. So all I'm going to care about is the actual signs, right? So why don't I just write the signs down that would have occurred if I plugged the negative x in? So if I plug in negative x into odd values that have odd powers, what ends up happening to the sign? They switch. So that's a positive, I'm going to write negative. I'm jumping to the 5. That's a positive, I'm going to write negative. That's an odd right there. That's a positive, I'm going to write negative. That's an odd. That's a negative, I'm going to write positive. But if I plug it into evens, what happens? Nothing happens. So I'm going to keep that plus, keep that negative, keep that negative. And then a constant is a constant. It's always, it's constantly the same. So nothing changes. And now I'm going to count again. So when I count the second time, I get negative to positive. That's a change. Plus to minus is a change. No changes through here. Negative to positive, positive to negative. So that's 4, right? And by the way, almost always when you do this, these two numbers are going to add to that 7. Not always, but almost always. So expect that to happen. If it doesn't, maybe you made a careless error. And let me ask you this. What does it mean if when I go to count, and by the way, that 4 would mean 420. I'll get to that in a second. But what does it mean if this were to happen? You do all the math, you count up and you go 3 and 3. There's 7 roots. I guess there's 1 left. What does that mean?
That means that there's an imaginary.
Do what? You did it incorrectly. Guys, imaginary numbers have to occur in what? Pairs when I have real numbers. If that happens on your test, I end up counting off for the careless error of not counting. I usually can look up there, and this is what's happened. I usually look up there, and it's like 1, 2, 3. They just forgot to count one. But if you write an odd number under imaginary, now you're showing me a second error. You're showing me that you don't know that imaginary numbers have to occur in pairs. You can't get an odd number. So if you get an odd number, you've counted wrong. Go back and be careful. Maybe you wrote down the wrong signs. Maybe you just forgot, like I did here, to do that extra 1 and get 4. But go find it, because if you write odds there, I'm like, okay, not only did they make a careless error in counting, but now they don't know about imaginary numbers occurring in pairs, and you end up getting counted off for two mistakes. All right? But because I got 4, you know it's 420. Don't write 420 and start drawing lines everywhere. I won't know what line's going to what. I mean, look at this. 420. Don't write this. And then I see people going, okay, it could be this, or it could be I mean, what in the world? I have no idea. Do you mean 124 or 122? Is it 340 or 342? That's confusing to me. So don't do this. What you want to do is whatever you get for negatives, just write it out for each number. And then how do you do the imaginaries? As you're following each path, how many do you have to have?
2.
Total. 7. The number of the highest power. So 7. So they have to add the 7. So just make them. If you go 3 and 2 is 5. Oh, 2 more. Sorry. 0. This is not right. 0, 2, 4. 2, 4, 6. Sorry. So 2. That needs a 2. That needs a 4. That needs a 2. That needs a 4. That needs a 6. Make sure that each path has it. Now you're welcome to do this. Okay, positive, negative, imaginary. I could have 3 positives and 4 negatives and 0. 3 positives, 2 negatives. I'm sorry, 2 negatives and 2. Or I could have 3 positives, no negatives, and 4. You could do that and then go and say, all right, I could also have 1 positive, 4 negatives and 2, or 1 positive, 2 negatives and 4, or 1 positive, no negatives, and 6. I could write it out like this, but I think this is just easier. And I'll know what you're talking about. But this is how your books key wrote your answers, I believe. I like it. But is that helping me? Say you are starting to solve this ugly thing, and you found your first positive root. Sweet. Now I know exactly what's going to happen. No, I don't. I still don't know how many negatives I'm going to have. I still don't know, but I do know that it's possible there's only 1. But what if there's 3? Now, it might help you when you find your second positive, because once you find your second positive, what do you know? There's 1 more, but guess what? It doesn't even have to be in the possible rational roots. Is this positive? Is this positive? Yeah, they're both positive. Type them in your calculator, you get positive answers. It could be talking about that, which is not even in your listing of possible rational roots. So Descartes' rule to me is so average at best at really helping you, unless you really see sign changes in a pattern that would be conducive to going, oh, wait, they're all the same, no sign changes, no positives. If they're all alternating and all the powers are there, sweet, no negatives. That's when it's helpful. But beyond that, yes, I will ask you to do this once.
Thank you.
Yeah, man.
Number 15 on page 63.
It's 62.
53.
You said number 15? Okay, so I'm asking you to solve. So if you didn't have this graph, what would you do? And I just said solve. No graph, solve.
You would take, you could like do like plus and minus
So-
1 and plus and minus 3.
So the factors of the three, which would be plus or minus 1, plus or minus 3, and you put them over,
The factors of
which is over 1. So that's it. So you have 4 guesses for the roots, right? And it wouldn't take that long to actually go through those, right? So you start with 1 and you plug it in and it actually works. And then you try -1, you plug it in and it actually worked. And then you try 3 and it didn't. And then you try -3 and it didn't. And you go, crud, I need to have 3. And then you go, oh, let me go back and try 1 again. And you try 1 again and it wouldn't. Then you go back and try -1 again and it would. And you'd have all 3. But with the picture, you got a huge hint. Because a root is where what? Where y is 0. So that means where it touches or crosses. And it crosses at x equal 1. And it bounces at x equal -1. But if it crosses, that's a single root. If it bounces, it's a double root. So I'm literally giving you that hint. If you didn't know that, now you do. Now, I still have to find the last 2. So literally, I know that one of my roots is 1, and one of my roots is -1, and the -1 is actually a double root. So literally, I have 3 of my 5 roots. All I got to do is find the last 2. Right? That's a gift. If I didn't give you the picture, though, you'd still get there. Keep checking, keep finding. I'm just giving you a gift. Now, you're still not going to be able to get there without what? Shrinking it down. You got to shrink it down. And the only way I know to shrink it down is to synthetically divide. I'm just giving you a hint with the picture. All right? So let's just get started. I can see that it crosses at 1. Let's just divide that 1 into 1, 3, 4, -5, -3. 1, 1, 4, 4, 8, 8, 3, 3, 0. Hey, what does it mean when I divide that 1 in and I don't get a 0 remainder? You know it's a root. It crosses at 1.
You made it here, what's there?
You what?
You didn't put next squared and everything, because it goes from 3 to 1.
You're right. And how did that still work? Unprecedented. 3, 4, 0. That would have been totally horrible on your test because it actually worked, which gave you a wrong another set. None of the other ones would have worked. And you would have been stuck in this holding pattern, totally questioning reality, going, why is this happening? That happens from time to time. I'll see somebody who will divide incorrectly but get 0, and one that's not a root, they'll think is, and they'll go, Mr. Hurry, I've checked them all, look. And I'll go and I'll look at them like, oh. And the best thing I can tell you is just start over. Erase everything, free your brain, and recheck. Don't remember anything you just did. And then usually they don't make that same careless error again, but that's normally when you make a mistake, it doesn't equal 0. But every now and then I'll see that and I'm like, oh. All right, so that would have been brutal for me here. So 1, 1, 4, 4, 8, 8, 8, maybe that was what, and then 8, 3, 3, 0. Good catch.
For these, you can still just solve it in normal way, right? Like you wouldn't need the graph there.
Correct.
You could just guess with the.
Correct.
Okay.
Yeah, but what if I gave you this, and this back number was 24, and this front number was 12,
Yeah.
right? And your possible rational roots, you're going to have a buttload of them, aren't you? But if you looked at the graph and went, wait, I can see that they cross at 6 and -3 and 2, I'm just going to use those bad boys and not worry about all this other stuff, right? That would be a much better problem. And the reason why I don't do that, you know how high and low the graphs go when you start getting really big values like that in there? Like it might touch right here and then go down to like -74,000 and then come back down here up to 100,000 over. And the graphs are really hard to shrink and get to fit on a page where they look normal, but whatever. So the first one, then what? -1, 1, -1, 3, -3, 5, -5, 3, -3, 0. And then because it bounced, -1 again. 1, -1, 2, -2, 3, -3, 0. Sweet. And I'm left with 1x squared plus 2x plus 3. Oh, sweet, that factors. No, it doesn't. Remember, don't get in the habit of factoring. I have people all the time that go, oh yeah, x plus 3, x plus 1. First of all, how do you know that's wrong? Because if my answers were -3 and -1, then wouldn't it cross at -3? And it doesn't, right? So that can't work. Or what if you went, hey, oh, it's x plus 3, x minus 1. That would work. Actually, it would if that was a -3 right here. But it doesn't. That would mean -3 and +1 roots. But that would mean 1 was a double root because it already worked once. That would mean it should bounce there, but it doesn't. And it still doesn't cross at 3. Guys, just expect the last two that you find to be unfactorable, that you're going to have to go through the quadratic formula. And by the way, even if you do use the quadratic formula and you end up with whole numbers and go, oh, this factored, it's not like it took that much time. I mean, look at the math. -b plus or minus 4 minus 4 times a times c. Two I root 2 all over 2. 2 cancels, and I get what? -1 plus or minus I root 2. So those are my last two. And then it's always good to actually write that. -1 plus or minus I root 2. Write this in brackets to really show your, and you don't have to indicate double roots. Right? All right, I got a lull right now. So I'm going to look at my notes and just throw stuff out that people miss a lot. See what you can do.
Oh wait, while you're right there, number 16, would that be a good one to use the rule?
What rule?
The positive, negative, and negative rule.
Yeah, because
Save you some trouble, wouldn't it?
Yeah.
Now he's saying, could you use Descartes' rule? Let's just say you didn't use Descartes' rule on number 16. It's okay, you'll get there. But this is what will happen. You're going to go, all right, to solve factors of 6 over the factors of 1. Okay, so that's it. So I've got 8 choices. All right, so you start going through there. Is it 1? Maybe, maybe not. Is it -1? And you go through there, start synthetically dividing. Well, if you had looked at this and gone, wait, plus, minus, plus, minus, plus, that's what? The number of positives is 4, 2, or 0. Lots of positives in play, right? But wait, when I go and change the signs, keep it, change it, keep it, change it, keep it, there are what? No negatives. I just saved myself 4 possible checks. Now, is that the end of the world? I mean, no. It's saving you a little bit. Just knowing that saved me probably having to do synthetic division 2 times, 3 times. So to me, it's worth it. Not to mention, I've literally asked the question, what 2 sign patterns are advantageous to know with Descartes' rule of signs? All the same or alternating? I've asked that question before, not every year, but I've asked it. So just knowing that's helpful. So I do exactly what Abdul did. I just give it a glance when I'm asked to solve and go, all right, is that going to be helpful? If it is, ooh, sweet, alternating. Or all the same. It means they're 0 positives. But that to me is helpful, especially if that 6 was 60. Oh, Lord have mercy. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 12, plus or minus 15, plus or minus 20, and plus or minus 30, and plus or minus 60. Have fun. That's a buttload you got to check. And that's if the lead number's a 1. But if you could eliminate all the negatives, well, now we're in business, right? I can get there so much more quickly, I can start checking them. Were any of y'all thinking, man, you can go through those factors quickly? I'm saying that when I taught Algebra 1 way back in the day, it was Algebra 1 for 9th through 12th graders. That was a lot of people. I mean, that was an interesting lot. A very motley crew. I mean, I had a kid in there once, I remember. It's the first day of class. Do y'all know the Duras? There's two Duras. There's
Jake.
no, the parents.
Coach Dura.
There's Coach Dura at the middle school, and there's another
No,
Dura
he's at Edgewood Elementary.
that's not a teacher, but his wife is Kelly. Do you know them? Okay. Well, their son, he won't even remember this. He's tall. I mean, the dad's tall. He's like 6'3" or whatever. When he was a 9th grader, he was in my class in 93. He was like 5'2". He was the shortest little, he went out for basketball. I remember Coach Shep or whoever the coach was like, dude, you're never playing. You're too tiny. And then he grew and became really good. And he actually was really, really good. But I remember him sitting in class and I remember his feet, I don't even know if they touched the floor. It would just like dangle from the desk. And that I had 9th graders like him in there. And then I had full grown women. I mean, I had seniors. Like I had a girl that was, she must have been held back. She was 19 in my class, full grown woman. And that was back before like dress code. So she would like wear the little tank tops, whatever. And I remember she came in here and sat down. This dude, he didn't learn anything. I think she dropped out after a week. For that first week, he was like, her name was Maria, I remember. He would just stare at Maria. I mean, that was the class I had. It was like, I just was glad they were there. I mean, these poor kids. I mean, back then you only needed 2 years of math. It was an interesting life. Why am I telling this story?
Entertainment.
Your factory. You know your factory ability.
You were talking about how quickly, you can.
Because you had a big class.
Oh, yes. So I would have my notes up, and we would have the overhead projector up, and I would say stuff like, all right, guys, and I would just mess with them because they weren't clever enough to figure this out. Most of them. I mean, actually, the Dura guy was Scott. He was. But a lot of the other ones were like, what? Yeah, it was a weak group, the older ones especially. But anyway, I remember doing stuff like, all right, guys, what is 2175? We got to multiply by 365. That's, what is that, 4,264,000? Well, I have the number written down, but I would act like I was doing it in my head, and I could see them, they'd be like, it's amazing. And I did that for like almost the whole year. I finally was like, you guys are suckers. Do you really think I can multiply 3-digit numbers together in my head? So I could have just been throwing numbers out, is what I'm saying, and you were like, oh, that was going really quick with this. All right, let me just throw. Anybody got a question? I'm going to throw stuff at you. Okay, you didn't have to do it, but I just want to talk about it. So here's our function. I'm making this stuff up, reminding you about some stuff we know. First thought that comes to your head. Oh no, that's called a red flag. Would I really give you this problem if I really expect you to plug -7 in? That means there must be another way. What's the other way? What about synthetic? Because every year I have somebody who will do synthetic division, and then for their answer, they circle the polynomial. I'm doing synthetic division to get what? So the remainder with synthetic division is the same as this? You're right. Is there any guarantee the remainder is going to be any easier to get to? I mean, you're doing synthetic division. Those numbers can get ugly. No, but probably what?
You set it up.
I probably set it up to be nice. And I did on something like that. So synthetically dividing, -7 into 5, 34, 50. I mean, those numbers are kind of big. Dang, see? 7, 6. Wow. 7, 6, 5. So that's the kind of stuff that's great when you guys come up here and do it, and I'm just doing it for you, right? Not even thinking. Like I should go, yeah, good, I meant to do that. But it's very easy to forget zeros. You get hasty, you're on the test. 7, 6, I'm missing the 5. 4, 3, 2, 1, constant. All right. 5, negative 35. Negative 1, 7. 7, negative 49. 1, negative 7. Negative 9, 63. 3, negative 21. 1, negative 7, 3. Don't circle the polynomial. It's the remainder. It's the same as this. Now, what happens as you're doing this? When these numbers start getting worse and worse and worse and worse and worse, you probably forgot a sign, maybe a 0. I mean, look what happens. If I don't have that 0 here, right, look what happens to my math. Forget the 0. 7, 57. What? Negative 399. Mr. Hurd, you stink. Negative 2807. I mean, you see that happen. Something happened. It might just be a negative sign. It might be a 0. But those are red flags. You know it's not typically going to happen. So catch that stuff. So I would have caught that as I did it, but it's better to catch it from the start. You don't have to erase so much. All right. What about this? I'll take it. Oh man, I can't do 2 to the 120th. That's not going on. He must want me to synthetically divide. Whoa, synthetic division? 120 spaces? It's a lot of zeros to fill in. Both red flags go up. What do?
Stuff's getting canceled.
Maybe. The third, and this is more of a math team, really a math team level question. What's possible? You can see it. Plugging a 2 in, ugh, looks really nasty. Synthetically dividing, lots of zeros. If that happens, be a little creative. Plug a 2 in there and you get 6 times 2 to the 120th minus 48 times 2 to the 117th minus 7 times 2 to the 61 plus 14 times 2 to the 60 minus 6 times 2 to the 4, that I can do, plus 2 times 2 cubed, that I can do, plus 10 minus 1. Okay, so I'm fine with that stuff if I have to do it. This is the troublesome stuff. But wait, isn't 6 3 times 2 times 2 to the 120th, which gives me 2 to the 121? And isn't this 3 times 16, right? Which is 2 to the 4th times 2 to the 117, which is what? Another 2 to the 121? And if I have 3 2 to the 121 subtracted from each other, wouldn't all that go away? That's a possibility. That kind of stuff happens. You see it again. I have 7 2 to the 61, and here I have 7 times 2 times 2 to the 60. Well, what's that?
2 to the 60.
So a positive, negative, those are going to cancel. And then I've got negative 96 plus 16 plus 10 minus 1. That I can handle, right? You with me? Think about little outside the box stuff like that. What do we got? 10 minutes? Okay, here we go. x to the fourth minus 9x cubed, 23x squared minus x minus 34 equals 0. Solve. Hint. 4 minus I is a root. How do you know that?
Because they're rational.
Because the coefficients and the constants are real, which means these occur in conjugate pairs. So not only is that a root, but also 4 plus I. Now you have 2 of your 4 roots, right? You've got 4 plus n minus I. You've got 2 more to find. Should you take the possible rational roots? No. Yes. Should you take the possible rational roots and start synthetically dividing?
No,
It's logical, but what have I told you?
use the root that you already have as a vector.
I probably made all 4 of them irrational or imaginary. So it's not like it's a bad thought, but I'm telling you ahead of time, I'm trying to force your hand. Don't check those. Just don't. Okay? You're going to waste your time checking all 8. And there's no sign pattern that's helpful. So how do you do it?
Use 4 plus n minus I.
Okay, so which one do you want to use? 4 minus I? Now, do you have to synthetically divide them in one at a time? So there are a couple people in here that I think, wait a minute, couldn't you just use the sum and product rule and make a big factor out of those 2? And if I did that, I could long division it in and shrink it down that way, right? In my experience, it's usually only the people with strong A's that have success with that. I'm just telling you that's what I expect. Doesn't mean it's beyond your, I'm just saying there's so many little ways to make errors, and you don't find out your error until all the very end of the long division. You're like, crap, where was my error? It's just harder to find to troubleshoot. But with synthetic division, you find an error immediately. You get immediate confirmation 0, immediate conversation 0. Are y'all tracking with me? So my advice to you is to go with synthetic division. But if you want to go the sum and product rule route, totally fine with me. So here's synthetic division. And again, I would encourage you to leave some space because you're going to be writing binomials in there. And again, it only gets ugly twice. And if ugly's foiling, I mean, it's algebra 2, right? How hard can foiling be? We just got to be careful. I know you know how. Just slow down. So drop the 1, multiply. Add, and what do you get?
Negative 5 minus I.
-5 minus I. Multiply. Okay, step 1, this would be the first, what I call annoying, difficult part. Slow down. What do I get? -20, -4i, positive 5i, positive I squared, which is, and that gives me -21 plus I. Add 2 plus I. Crap, I gotta multiply again. All right, second step that's ugly. 4 minus I, 2 plus I. Slow it down. 8 plus 4i minus 2i minus I squared plus 1. 9 plus 2i. 9 plus 2i. Add 8 plus 2i. Now, what did I tell you about that last step? If it's a conjugate, you're good. Now, it doesn't look like a conjugate right this second, but if I factor a 2 out, what do I get? Ooh, the conjugate. So I know I did it right. That's a hint that I did it right. And if I did it right, what am I going to get when I multiply it out?
34.
And I just saved myself a little time. But if you want to foil it, if you're like, I love foiling, then foil away, and you're going to get 34. All right, so you proved that this is why I say you get instant gratification, right? You know it went in. And then you just go to 4 plus I, and this is going to be a walk in the park, right? So drop the 1, multiply. 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 Double R. And I'm there. So, was it that bad? Mr. You lied to me. You told me that wouldn't factor. You're right, it did. Because it does. But it went on test. Right?
Let's go.
So, right here it did negative b, but I'm still gonna just assume that it wouldn't. 4ac over 2a, 1 plus or minus root 9, 1 plus or minus 3 over 2. 4 over 2 is 2, negative 2 over 2 is negative 1. So those are my last two. But it's not going to happen on a test that way. If I give you those, I'm trying to force your hand. This is a terrible way to demonstrate that. But don't think, oh man, I'm going to show him on the test and beat the system. I wouldn't try that. 4 minutes. You sure there's nothing else? Hey guys, if you do the checkup, if you do the review, if you've done the homework problems, I can't see how you're going to be in trouble unless you just haven't done that and haven't figured it out. I'm here after school if you want to come in and ask some questions. But I'm hoping for good things tomorrow. All right? Right.
No, I got this. See how it goes.
They're not splitting into
I think so. You did.
Not that hard.
What did you get on the last